Okay, there's a question on how to find the equations of tangent and normal lines, specifically with trig functions. So let's go ahead and work this one out. This is good practice just in general. How do I do equations of tangents and normals? And also good practice with trig. So whenever I think equations of tangent and normal lines, the first thing that comes to my mind is equation of a line. So I'm going to start with my y minus y1 equals m times x minus x1. Now there's some variations to this, and we did do like a calculus version of this, and we said, well, my y1 is really my f of x, whatever that is, or f of, I should probably write it this way, I should probably write it f of a, because it's at some particular x value, so let's call that x equals a. So there's my x equals a. And then m is really my derivative, my f prime, at some point, times x minus a. So, and then we could even take it one step further, y equals f prime of a times x minus a plus f of a. I would not go any further than that. So that's the furthest I would go, and either one of these two is acceptable. Let me highlight those. Either one of those two is fine as your final answer. We're just going to literally plug into those. Okay? So I'm going to encourage you to just stay with the first one there. And for the reason of space, I'm going to go ahead and hopefully it'll let me erase this. Erase this, and we'll go ahead and just plug in to get my final answer into that equation. So let's keep this, and we'll come back to this after we get some stuff to fill it. So I'm going to keep this, and my answer will go right there. So I'm basically looking for, this kind of helps me with what I'm looking for, f of a and f prime of a, because I already know that my a value is this pi over 4. That's my specific x value, pi over 4. So I can rewrite what I have so far. Y minus not sure equals x minus, and I'm going to go ahead and put that pi over 4 in. So I'm really looking for the derivative, which is my slope, at some point, and then I'm looking for an actual functional value. So a lot of times we just jump straight to the derivative, but you know, I'm actually going to start with, let's find this f of a, which is just my y value for my function secant x at pi over 4. So I've got f of x is secant x. And I'm trying to find f of pi over 4. So that's secant of pi over 4. So I don't know about you, but I think of secant as 1 over cosine. And cosine of pi over 4 is radical 2 over 2. So I've got 1 over radical 2 over 2. And 1 over radical 2 over 2. Well, that can be simplified. So that is a potential answer, but we can make it better than that. If I multiply by the reciprocal, I get 2 over radical 2. And then if I rationalize it and multiply by radical 2 over radical 2, then that's going to give me 2 radical 2 over just 2 in the denominator, which is radical 2. So that is my y value, my functional value at pi over 4. So okay, that got a little bit messy, but hopefully you've got that that's radical 2 was my final answer there. So I'm going to put in the radical 2 right here. And then the only thing I have left to do is the calculus part of it. I haven't really done any calculus yet. The calculus part of it is to find the derivative at a point. This part right here. So I need to find f prime of x. So let's go back to our function is f of x. That means f prime of x is derivative of secant, which is secant x times tangent x. So, and then I want derivative at a point. So let's kind of move that up so I can get a little bit more space here. So derivative at pi over 4. is secant of pi over 4 times tangent of pi over 4, which is secant of pi over 4 is 1 over cosine of pi over 4, which is 1 over radical 2 over 2. And tangent of pi over 4 is 1, because that's sine over cosine, which is radical 2 over 2 over radical 2 over 2. So I'm getting 1 over radical 2 over 2 times 1. They're both positive because I'm in my first quadrant. So that's going to give me 1 over radical 2 over 2 is the same thing that I had here, which simplified to a radical 2. So I'm going to skip the simplification there because it looks like my answer is just going to be the exact same. So that is my derivative, which is going to come up here and plug right in here. And it looks like my y value and my derivative are both radical 2, but I obviously got them doing different methods. So this right here would be your equation of the tangent line. That would be the line that has the same slope as the function at that point. If you zoomed in and it looked approximately linear, it would have a slope of radical 2. And the actual point would be pi over 4 comma radical 2. So there's my x value and my y value. Now the question also said to find the slope of the normal line. So let's see if I can give myself a little more room. You know what, let's just go to a new page. Oh, there we go. Okay, I think I'm still in the same video. If not, then I'll upload 2 videos. But I'm going to recall what equation I just had. So my tangent line equation was y minus radical 2 equals radical 2 times x minus pi over 4. So my normal line, they're going to be passing through or connecting with your function at the same point. So the only difference is, and you could graph this on your calculator, I don't know off the top of my head what it looks like, I'd have to do a graph of the secant, but if you have some point, and let's say you have your curve going like this and intersecting at that point, your tangent line that we have right here is going to be that line passing through that point, and your normal line is going to be the opposite. It's going to be perpendicular to it, but still going to pass through that point. So what I'm trying to get at is your x and y value are going to be the exact same. It's just your slope that's going to change. So this point right here in question, that point is my pi over 4 comma radical 2. That's the x and the y value of that point on my secant graph. Again, that's probably not what the graph looks like because I'm just drawing up a quick thought sketch there. But what I'm trying to do is figure out the slope, and the slope of the perpendicular line, I have to take my slope of my tangent line, and I've got to make it the, whatever the relationship is for the slopes of perpendicular, and that happens to be opposite reciprocals. So one answer would be a -1 over radical 2. That is the opposite reciprocal of radical 2. We generally don't like negative, or we don't like radicals in our denominators. If I take -1 over radical 2 and rationalize it, then I'd be multiplying times radical 2 over radical 2, which gives me a negative radical 2 over 2. So that's probably what most people would like. Either one, essentially they're equivalent to each other. So this or this could be in there for your slope, okay, of the normal line. Hopefully that helps. There are some other ones for you to try. Take a look at that Google Doc, and you should have some examples that you can try. Definitely in review 2, there was some that were similar.